Hello, I'm Andrew Plumb. I'm a senior lecturer in medical imaging at University College London, and this is Professor Steve Halligan, also from University College London. And we're going to talk about our paper, Terminal Digit Preference Biases, Polyp Size Measurements at Endoscopy, Computed Tomographic Colonography, and Histopathology. So the idea for this paper was one of Steve's, I think, and he'll tell us a little bit more about where the idea came from.
Yeah, so this was this came up a little while ago. We were conducting two parallel randomised controlled trials of CT colonography versus barium enema and CT colonography versus colonoscopy, and we were implementing the analysis plan, and we're looking at the size of the polyps recorded by participants in the trial. And I remember I was looking with our statistician at, in fact, it was the statistician in charge of the data monitoring committee, a very competent and well-known guy called Doug Altman. And Doug had looked at the distribution of polyp sizes and noted that there were a whole load of 10mm polyps, but there didn't seem to be any 11mm polyps, and there didn't seem to be any 9mm polyps. And he expressed this as a very obvious case of terminal digit bias, and explained to us the concept that it's very common for people to focus on identifiable thresholds, especially where they know the biological significance of that threshold. So, for example, there's a big a priori difference in your mind between a 9mm polyp and a 10mm polyp, if you're aware of the polyp size as you're making the measurement. And so we've got to thinking, well, why don't we look at this data or these data in greater detail to see if that's a valid observation that this bias is present throughout the data set in the trial. And while we're at it, surely this bias might exist in other scenarios, for example, in screening programs or for other technologies, and that's how we brought Andrew on board.
Yeah, so at the time I was doing my PhD, and I was working with data sets from the English bowel cancer screening program, mainly looking at CT colonography, but at the same time we were also looking at the endoscopic data sets and the histopathologic data sets as comparators. And so we thought it would be a good opportunity to see if the same phenomenon was happening across a bowel cancer screening program. So a slightly different clinical setting to a trial scenario. And so what we did was that we got all of the polyp sizes for the three techniques or three means of measuring it, i.e. endoscopy, radiology and histopathology, for both the screening dataset and the randomised trial dataset. And then with advice from Doug Altman, the statistician that Steve's mentioned, and the other SIGAR trial statisticians and our own statisticians, we were able to analyse this dataset to show that there was indeed an excess of polyps accumulating at sizes that correspond to essentially to round numbers, so any multiple of 5. So there were many more polyps of 5mm, 10mm, 15mm, 20mm and so forth than we would expect, because we'd expect the distribution of polyp sizes to be relatively smooth. There's no biological reason why there should be a spike of polyp sizes at 10mm or 15mm, for example. But we found that this phenomenon was very common and was robust. So we then thought, well, does it actually matter? Does this make any difference to patient care? How much of a difference is it likely to have? And so to work that out, we kind of had to model roughly how many polyps we were expecting there to be and how many more of them were measured at 10mm plus. And for each of the modalities, it turns out that you inflate the number of 10mm plus polyps by somewhere in the region of 3%, 3 to 5%. So in theory, that means that we're getting excessive numbers of colonoscopic surveillance or referrals to colonoscopy after CTC as a result of this bias. So what does that mean for the future? What can we do about it? What are the next steps? Well, I mean, there are already steps in the screening program, for example, to highlight this phenomenon. And in the histopathology reporting requirements document for histopathologists in the screening program, they're already told to guard against digit preference bias. So I think that message could probably be disseminated more widely to endoscopists and radiologists, not just in the English screening program, but more broadly. Steve, have you got any other?
No, I guess it's just a case of people being aware that I think what's important about these data is it if you read the paper, it shows very unequivocally that there are these spikes for histopathologists, for radiologists and endoscopists when they're measuring lesions. So I guess being aware of these data and being aware in your mind that there's potential for bias, and trying to avoid that. I mean, the whole thing of measurement is a very thorny issue, actually. I mean, Doug Altman has often said to me that we don't really know the size of anything. Everything almost has some sort of error around it. A ruler may not be accurate the way that one person measures something, and by the time you get to the scenario where you've got an open pair of biopsy forceps and you're trying to assess the size of a polyp, there are ample opportunities for inaccurate measurements. But I guess it's then a case of how important is that inaccuracy and what are you going to do about it. And clearly the first step is to be aware that there's a potential for bias and try and guard against it. I mean, in many scenarios, perhaps the best thing you could do is for the person who's making the measurement to not be aware of the measurement that they're making. So we've done studies in the past where if we're measuring something with software calipers, the measurement, the value of that measurement on the computer screen is being blinded from the person making the measurement. But that sort of thing is more applicable, I think, to a research scenario. I can't really imagine that sort of scenario working when you're reporting a CT or when you're doing an endoscopy, especially. But maybe it's just one of those things just to be aware of it and guard against it. As I say, when we looked at the original data, it was amazing how there were just no 9mm polyps, and I guess next time you measure a polyp and it looks like it's 9mm, well, you don't push it down to 8 and don't push it up to 10, depending on what you had for breakfast that day. It's 9mm.
That's a good message. Okay, well, thank you very much for watching this video, and I hope you enjoy reading the paper.
Lovely. Thank you very much.